Hey guys, what's up? It's Miss DeAngelis here. Today we're going to go over a little bit more history of the periodic table, kind of discussing how we're going to put everything together between elements and Bohr model, and where those metal, nonmetals, and pesky metalloids are on the periodic table, and what some of the physical properties are and what some of the chemical properties are of these features. Okay, so let's talk about this cat, this chemistry cat, Dmitry Mendeleev. He was a Russian scientist born in Siberia, and he is known as the father of the periodic table of elements. The table is designed to help you predict chemical and physical properties of elements. And guys, that has to do with where the element is located on the periodic table. I think I kind of mentioned that before, that we can kind of predict what some of these chemical and physical properties are of these elements based on their location. So what Mendeleev did is he looked at the elements and he wrote facts on paper cards for each element. The melting point, the density, the color, the atomic mass. Like, he actually had this stuff on index cards. And then he placed it all out in front of him, and he started to notice that there were some patterns in this table, and he was able to predict some of the properties of these undiscovered elements that were yet to come. So during his time, in 1869, not all 118 elements were actually on the periodic table, but he did leave some place cards for some of these elements that had not been discovered. So today, elements are arranged in order of increasing atomic number on the periodic table. And if you'll notice here, boron is 5, carbon is 6, nitrogen is 7, oxygen 8, and so on until we get to neon, which is 10. And then there is uniconium, I think. I don't know, maybe it's for unicorns. But anyway, that's 118 on the periodic table. And so they are in order exactly from 1 to 118. Okay, so elements are located in 3 main categories on the periodic table based on their physical properties. So if we were to look at the periodic table, you can see that this pinkish color are the metals, the green here are the metalloids, and the nonmetals, which are pretty much your gases. Elements that are found in a gas state are going to be over here on the right. And by the way, the metals are pretty much in a solid state. So physical properties. What's a physical property? Okay. So physical property of matter can be observed or measured without changing the substance. So like ice cream is cold, a pot can be hot when you boil it. What's the density and mass of an object? Examples of physical properties: texture, color. Guys, remember ductility. Ductility is being able to take an element or the metal and kind of make it into that long, thin wire. Density is how tightly mass is packed in an object. Malleable means that it can be pounded or rolled into a shape. So think of like an iron pan that mom would use to cook with. And mass is how much matter is in an object. So again, here's just another picture with the metals are always on the left. The nonmetals are always on the right. And the metalloids are on the staircase. So we call this the staircase of the periodic table, and that's this purple section right in here. Okay, so let's talk about metals. So metals are made up, let's see, there's 88 elements to the left of the stair step. They are high in luster, which means they're shiny. They're good conductors of heat and electricity. They have high density, which means that they're really heavy for their size. High melting point. Ductile, guys, again, being able to be pulled into long, thin wires, and malleable, which means that we can shape it. Next, let's talk about the nonmetals over here on the right. What is it that we know about the nonmetals? Well, their physical properties are that they're dull, and they're brittle, means that they can break very easily. They're not ductile, so we are not pulling these things into wires. They are not malleable. Well, they can't be. We can't bend them into anything if they're brittle. So that's how we know that they're not malleable. They have a very low density and a very low melting point. Okay, now let's talk about these metalloids over here, then these purple and the stair step. The physical property of a metalloid: it's solid. It can be shiny or dull. It can be ductile. It can be malleable. It can conduct heat and electricity, but not as well as metals. And again, a lot of these metalloids are used in semiconductors, okay, like your computer parts. So scientists organize elements according to their physical and chemical properties. So there you go. The periodic table is designed to help you predict what an element's physical and chemical properties are. And then from here, you can also figure out what elements will bond with each other using the periodic table. And that has to do with the valence electrons, the number of valence electrons in the outer shell. Okay, so elements, as you know, because we've done this many times, are arranged in vertical groups. Those are called the families, but don't worry about that. We're just going to call them groups. And then across, they're called periods. And as you know, the groups represent the number of valence electrons in the outermost shell. And horizontally in the period, it tells you how many energy levels or rings are around that nucleus. Okay, so if you looked at one atom of every element in a group, you would see that each atom has the same number of valence electrons. So if we go back, beryllium, magnesium, calcium, I think it's strontium, all of these elements here are going to have the same number of valence electrons. So look, so this is beryllium. It has 2 valence electrons, one here and one here. And then this is magnesium, and look, it has 1, 2 valence electrons, but you'll notice it has different energy levels. So this one has 1, 2, and magnesium has 1, 2, 3, which means they're in different periods, but they are in the same group when it comes to the number of valence electrons. So valence electrons affect the way an atom bonds, which determines many of the chemical properties of the element. This is why elements within a group usually have similar chemical properties. So again, the elements that are in this group have very similar chemical properties. And that's true for every group that is on the periodic table. Let's talk about chemical properties. A chemical property is a characteristic that is observed when a substance changes into a different substance and we can't change it back. So metal that rusts, you can't change it back. I mean, I know I had some kids last year that were like, oh no, Miss DeAngelis, we could put like Coca-Cola on metal and it takes the rust off. It takes the rust off. It doesn't turn the rust back into the original metal. Okay, that's the big difference there. Examples of chemical properties are reactivity, combustibility, meaning can we set on fire, corrosion. That's happened to me a few times. These batteries, the acid comes out and it destroys whatever electronic it came from. Flammable, is it capable of igniting? Tarnishing, think of mom's silver and how it tarnishes. And you have to use that silver polish to get that oxidization off. And rusting or oxidization actually is rusting or tarnishing. So these are our metals, like we talked about. These are our nonmetals. And guys, this group is not reactive. Okay, this group is not reactive, the one that's all the way on the right. And that's because its outermost electron shell is full. But over here on the left, these guys are the most reactive. Okay, over on the left, they are very reactive, very reactive. If you looked at an atom from each element in a period, so if we took one of these colored stripes, what would we see? Each atom in the same period has the same number of electron holding shells. Here's an example. So they've taken this period starting with potassium, and you'll notice that it has 1, 2, 3, 4 energy shells. And we can go over here to iron, number 26, and it has 1, 2, 3, 4 energy shells. And again, over here, which is krypton, and it has 1, 2, 3, 4 energy shells or energy rings. So every element in a period has the same number of shells. Okay, guys, that's it. That's going to wrap it up for today. Please complete your ed puzzle. And again, make sure if you do want that credit, you are filling out that Google form. Again, fill out the Google form if you want credit. Any questions, you can ask me when you see me. Talk to you soon, guys. Bye.